A very good morning to all of you dear students. This is Dinesh Mehbubani in the video lecture series of numerical methods in chemical engineering. We have started unit number 6. The name of the unit is numerical differentiation and integration. What we have completed in the numerical integration? In numerical integration we have already covered two topics. The first one was trapezoidal rule and the second one was Simpson 1/3 rule. See, Simpson 1/3 rule is also known as Simpson's rule. If any numerical is asked in which only Simpson rule is written, then you have to apply Simpson 1/3 rule. Remember. Okay. What is the basic difference between trapezoidal rule and Simpson 1/3 rule? The trapezoidal rule, the formula is different. Apart from the formula, if we study graphically, then in trapezoidal rule we are taking only two values, x0 and x1. That means we are taking 2 points, x0, y0 and x1, y1. In Simpson 1/3 rule, we are taking 3 points, x0, y0, x1, y1 and x2, y2. And in Newton-Cotes formula, by applying n is equal to 1, I will get trapezoidal rule. By applying n is equal to 2, I will get Simpson 1/3 rule, and the formula is totally different. Okay. In Simpson 1/3, we are taking parabola. In trapezoidal, we are taking straight line. Okay. Now the third method and the last method of this chapter is Simpson 3/8 rule. Okay. What is the basic difference in the other methods and Simpson 3/8 rule? Let us study that. In Simpson 3/8 rule, we are taking n is equal to 3. In Newton-Cotes formula, we are placing n is equal to 3. We will get Simpson 3/8 rule. But instead of 2 or 3 points, here we are taking 4 points on the curve. See, y is equal to f of x, a curve will be given. Y is equal to f of x will be the given curve. And we have to take 4 values on the curve. See, this is the given curve, so I am taking 4 values here. Okay, so my integral will be from x0, x1, x2 to x3. Okay, so I am taking the first integral from x0 to x3. Okay, and this is the interval, width of the interval, and these are the points x0, y0, x1, y1, x2, y2 and x3, y3. So taking these 4 points on the curve, okay, I am finding the area of this integral. So this integration is found. Then again I am taking more values. Then again I am taking the integral. Again I am taking more values. So this will be x4, x5, x6 again and so on. And I am finding the last integral. Okay, the last integral will be from xn minus 3 to xn, and by adding all these integrals I can derive the Simpson 3/8 rule. Okay, and here I am taking the third order polynomial, so the higher order derivatives, the higher order differences after 3, so del raised to 4, del raised to 5, we have to neglect. We have to only take the differences up to third order. See, let us place n is equal to 3 in Newton-Cotes formula. Before that, we will first of all write Newton-Cotes formula, x0 to xn, f of x dx. This can be written as h n y0 n square by 2 into del y0 plus n cube by 3 minus n square by 2 into 1 by 2 del square y0 plus 1 by 6 n raised to 4 by 4 minus n cube plus n square into del cube y0. Okay, here you have to place n is equal to 3. So I can write here 3 y0 plus 9 by 2 del y0 plus 1 by 2. 27 by 3 is 9 minus 9 by 2 into del square y0 plus 1 by 6. 81 by 4 minus 27 plus 9 into del cube y0 and so on. See, by using the different formulas of del y0, del square y0, I am not solving the whole expression, I am directly writing the answer of the first integral. See, here I am taking the first integral from x0 to x0 plus 3h. So the value of the first integral will be 3h by 8. (3h by 8) y0 plus 3y1 plus 3y2 plus y3. Okay, this is the answer of the first integral. My second integral will be from x0 plus 3h to x0 plus 6h. So, if I am writing from x0 plus 3h to x0 plus 6h, not x0 plus 6h. See, my second integral will be from x0 plus 3h to x0 plus 5h, and my answer will be 3h by 8 y3 plus 3y4 plus 3y5 plus y6. Okay, and by adding all of these integrals, my last answer will be like this: 3h by 8 first term plus last term plus 3 into sum of the terms excluding the multiples of 3, because the multiples of 3 are coming at last. Okay, so y1, y2, then neglect y3, then y4, y5, then y7, y9, y8 and so on, plus, see, multiple of 3 terms are coming 2 times. So 2 times into multiple of 3 terms, okay, y3 plus y6 plus y9 and so on up to yn minus 3. Okay, and this formula, see, this formula is known as Simpson 3/8 rule. What you have to remember? 3h by 8 first term plus last term plus 3 into sum of the terms excluding the multiple of 3 terms plus 2 into sum of the multiple of 3 terms. Multiple of 3 means y3, y6, y9 and so on. Okay, so in this way you can solve the numericals of this method by using this formula. Okay, let us solve a numerical on the basis of this. See, this is the given numerical. Evaluate the integral 4 to 5.2 log x dx using Simpson's 3/8 rule. See, before solving, first of all we have to find the value of n or h here. See, h we can assume or we can also assume n. See, the condition is the n should be a multiple of 3. The condition to apply Simpson 3/8 rule is n should be a multiple of 3. So if I am taking n is equal to 6 here, so what will be my h? To find h we require the value of a and b. A is equal to 4, b is equal to 5.2. So what will be my h? H is equal to b minus a upon n. Okay, so h can be found by 5.2 minus 4 divided by n. N is 6. So this can be found 1.2 divided by 6, that will be 0.2. So my value of h is 0.2. Okay, what is our next step? See, we have to find the values of y from the table. Okay, and we have to take the differences of 0.2. See, many students are doing mistake here. We have to start from the first value in the sense that we have to start from 4, okay, and we have to take the differences of 0.2. So 4, 4.2, 4.4, 4.6, 4.8, 5.0, and the last value will be 5.2. Now I have to find all of these values. I can find all these values in the calci. Okay, and we have to take ln of x. Why we are taking ln? Because log base 10 is not given. So we have to take ln here, not log. When we have to use log? Only when the log base 10 is given. Okay. See, find the values. ln of 4. What is the value of ln 4? ln 4, 1.3863. Then 1.4351, 1.4816, 1.52, 1.5261, then 1.5686, 1.6094, this is 6, okay, then 1.6487, these are the values. Then start giving numbers, y0, y1, y2, y3, y4, y5 and y6, and then we have to apply Simpson 1/3 rule. To apply Simpson 1/3 rule, we have to apply the Simpson 1/3 formula. And then we have to apply Simpson 3/8 rule. To apply Simpson 3/8 rule, we have to apply Simpson 3/8 formula. What is the Simpson 3/8 formula? To find the integral, I can write here 3h by 8, first term plus last term, okay, plus 3 into multiple of 3 into sum of the terms excluding the multiple of 3. So y1 plus y2 and y4 plus y5, and the last will be 2 into multiple of 3. See, multiple of 3 are 2 terms here, but we have already taken y6 in the starting, so there is no need to take y6 again. So here it will come y3. Okay, so this is the formula. By placing all of these values in the formula, you will get the answer. So the final answer of this numerical will be integration from 4 to 5.2 log x dx is equal to 1.8278. So 1.8278 is the final answer. Okay. Okay, let us solve one more numerical on the basis of this. See, what is given in this numerical? In this numerical, we have to find the integral from 0 to 3, 1 upon 1 plus x. Okay, n is equal to 6 is given, so h will be easily found. Okay, and we have to also calculate the value of log 2. Here again log 2 is given, so ln we have to apply. Okay, but before that, we have to find the value of h. H is equal to b minus a upon n. So 3 minus 0 upon 6. 3 by 6, that is 0.5. Okay. X, and here it will come 1 upon 1 plus x. We have to start from 0. Take the differences of 0.5. Find these values. Okay, 1 upon 1 plus x. 1 upon 1 plus x is 1. Again, 4 fixed should be there. 1 upon 1 plus 0.5, 0.6667. Then 1 upon 1 plus 1, 1 by 2, that is 0.5. Okay. 0.4000, 0.3333, 0.2857, then 0.25, then give the numbers y0, y1, y2, y3, y4, y5 and y6. Apply Simpson 3/8 formula. 3h by 8 y0 plus y6 plus 3 into y1 plus y2 plus y4 plus y5 plus 2 into y3 only. After placing all of these values in this, you will get the final answer. The final answer, not the final answer, but the value of this integral. The value of this integral will be 1.3888. Okay. See, this is the value of this integral, but still we have to find the value of ln2, that is log 2. How we can find that? See, if we will apply normal integration, then 0 to 3 1 upon 1 plus x dx can be written as ln 1 plus x, and the limit will be from 0 to 3. See, upper limit will be ln 3 plus 1, that is ln 4 minus ln 1. ln 1 is 0, ln 4 can be written as ln 2 square, so 2 into ln 2. Okay, so 0 to 3 1 upon 1 plus x dx is equal to 2 into ln 2. If I want to find the value of ln 2, then I have to take here 1 by 2. So ln 2 is equal to 1 by 2 into value of this integral, and the value of this integral we have already found. The value of this integral is 1.3888. So my answer for ln 2 will be 1.3888 divided by 2. So my final answer will be 0.6944. Okay, this numerical has been asked in GTU for 2 times. Okay, so you have to solve these type of numericals. We have almost completed all the methods of this chapter. We will come with a new chapter in the next lecture. Till then, have a good day. Bye bye. Do more and more practice, because practice is very much important. Otherwise, you will not gain confidence. Okay.